Hey guys, it's Miss Landry, and we are at the last of the Ionic naming program videos for you. This is all about transition metals. Now, transition metals are the metals that are found in the middle of the periodic table. We've kind of been waiting to learn about them. So, what's interesting about these, there's a couple things. First of all, they can make more than one ion. So, if you remember, we learned that the group numbers really help you understand how many valence electrons and what kind of ions they can make. Well, the transition metals can make more than one type. And if you look at this picture on the bottom here, when you actually put them into an aqueous solution, so when they're dissolved in water, which type of ion you have is going to create a different color. So for example, vanadium 5 plus right here is kind of yellowish, but vanadium 2 plus turns purple in solution. So it's kind of cool. Now, there's two new terms that you do need to know. Malleable, which means it can be hammered into a shape so it's soft enough to work with. And ductile. Ductile means it can be like pulled out into a wire shape. If you think of trying to think of an example, maybe putty, right? Like you can pull putty into a string. Well, you can do that with transition metals as well. So let's talk about how we're going to use them in naming. So let's start with going from the formula to the name, okay? Because I think this is probably the more challenging one, but I know you guys can get it. So let's practice this one, all right? So we're going to use Roman numerals for this. If you don't know how Roman numerals work, it's pretty cool. It's actually a pretty smart little system. So notice 4 is IV. If the number comes before whatever is next to it, oh, this came out bad. Let me start again. That's kind of messy. All right, IV is 4. If you notice, V means 5, right? And any number that's in front of it, you're going to subtract from that. So this would be 1 minus 5 is 4. Now, if the number comes after it, like here we have VII, right? So V, again, is 5. And then 1, 2, we're going to add those, so this would be 7. Don't worry if you don't get the Roman numerals too much. We're probably not going to go much higher than 5 on the Roman numerals. So and I think in your resource packet you do have this. So let's try it. So here's an example of one right here. SnS2. So we have Sn, which is tin. And as of right now, we know that that's a transition metal because we can find it on the periodic table, but we have no idea which ion it is yet. We do also have sulfur. Now we do know sulfur's charge, right? Sulfide, which indicates that's the ionic version of sulfur. Now sulfur is in the 16th family with oxygen and the others. So we know that it has a 2 minus charge. So we're good so far, right? Everybody's on track with that one. Okay, well, here's sulfur right here, 16, so it's 2 minus. Notice that in the equation, we have 2 sulfurs. Do you see that little subscript 2? So if we have 2 sulfurs, let me erase what I have on here. Sorry. If we have 2 sulfurs, remember that sulfur is a 2 minus, and I have 2 of them. That means my total charge for sulfur now is 4 minus, right? 4 minus, because I've got 2 sulfurs. Each one is a 2 minus charge. Now notice in the equation, I have only one tin, okay? So Sn is a single tin. There's no subscript. Since I only have one, what do I need for it to balance out? I need it to be a 4 plus. So I look at here. This is how you write 4. So therefore, it is tin 4 sulfide. That's how you do it. Let's try another one. Much like everything we've been doing, this is going to take a lot of practice, okay? So we're going to practice a lot. So Fe is iron. Again, we don't know its charge yet. Chlorine, we know, has a 1 minus charge. So if I put this here and multiply it by the subscript, I get a negative 2. Good so far? Yes, you are. Now, notice how many irons do I have? There's no subscript here, so that indicates 1 iron. That's hard to write. So if I have 1 iron, and I know that I have 2 chlorine, so a total of a -2. I know that iron has to be a +2. Makes sense, right? Because they have to balance out. So now I look at my Roman numerals. 2's nice and easy. It's just 2 little lines. So here is the name of that formula, iron 2 chloride. Okay, so now what we're going to do though is we're going to mix it up a little bit and we're going to try doing this the other way. And you'll be happy to know that this is so much easier. When you're given the name, it's very easy to go to the formula. Okay, so let's take a look at lead 2 chloride. The 2 tells you what lead's charge is. So lead, which is Pb, has a 2 plus charge. Okay, so I know that because it gave me the charge right there. Make sense? And then I know chlorine has a -1 charge because I know that from being in class. So when I put these together, what do I get? I get PbCl2 because I can crisscross now, right? Or I can just know how to balance. So that makes it super easy. I think these are probably the easiest of all the naming. So since chloride is a -1 and lead, Pb, is showing that you have 2 of them, it has to be, or sorry, that it is the Roman numeral 2 that tells you a 2 charge. Now, just to be clear, I want to make sure that I make this abundantly clear. This 2 right here does not mean that you have 2 lead atoms. That is not what that means. What that 2 means is that this has a 2 plus charge. Okay, just want to make sure that that is absolutely clear. Okay, so that one would be PbCl2. I want you guys to pause the video and try these. And seriously, I know it's important to try them, guys. Like, I want you to write these down. And pause the video and I will show you what they are. Okay, so let's try this one. Nickel 2 bromide. Nickel is Ni, and this indicates a 2 plus. Bromine, without the charge, bromine is a -1. So I need 2 bromines to balance out with the 2 plus nickel. Hopefully that's what you got. Let's try iron 3 oxide. This one's a little trickier. Not too tricky though. Iron, Fe. We know because of this right here, it's a 3 plus. Oxygen, you know from the class, it's a 2 minus. I'm going to do a little crisscrossing here, and I get Fe2O3, iron 3 oxide. Nice and easy. Last one, titanium. And again, remember what I told you, when the little 1 is in front of the V for 5, you subtract it. So this would be titanium 4 plus. And oxide. Now, oxygen we know is a 2 minus. So I'm going to need 2 oxygen. Oh, this is really hard. 2 oxygen, TiO2, because now if I have 2 oxygen, that will bring that charge up to a 4 minus, which will balance out my titanium 4 plus. And that's it. You got lots of practice to work on. So let me know if you have any questions. Thanks, guys.